All right, question one. First question. Might want to reference your notes. The pre-quiz. Tell your neighbor.
Yeah, big one.
Yeah. Wait on somebody else. So fine.
Correct answer is. Come on, kids. What we got? The slower it goes, the larger the value. Index of refraction. Speed of light in a vacuum over speed of light in material. Okay. Index of refraction. Tell your neighbor. Think. Correct answer is. Correct answer is A. The fastest light can go. The slower it goes, the higher this becomes. The faster this goes, the lower it is. The fastest it can go is the speed of light in the vacuum. 3.8 times, right, 3 times 10 to the 8th meters a second over 3 times 10 to the 8th meters a second. Good? That's the lowest it can be. All right. I'm going to do it for this side first, and I'll do it for this side. Okay, so we're going from air into water. Yeah, bends. Okay, now just a quick little thing here. There's multiple things going on. Here, at every surface, there's some part of this that is reflected and obeys the law of reflection. Some of it is refracted. You see how it's bending as it goes from air into water. Okay? So that happens at every interaction. Okay? Going from air into water. Some of this is reflected. Obeys the law of reflection. Some of it is refracted. Bends. Changes the path. Good luck, kids on the video. Okay. Can of fog. Sure, it's great for me. All right. All right. Give that one a shot. Have a conversation.
So fast, slow, slow, fast. Slow, fast is the way. Fast and slow is the way it is. Okay, so it should be air. Yes. And that's the way. I feel the real speaking. That's actually a crazy split. Like that's like a whole big question.
What do you say? Correct answer is. Correct answer is. Yeah, let's take it piece by piece. Okay. As we go from slow to fast, the slower it is, the what? Higher or lower the index of refraction? Higher. So N1 is greater than N2. As we go from slow to fast, as we go from a higher index of refraction to a lower index of refraction, does it bend away towards the normal line? It bends away from the normal line. Correct answer is A. Good with that? And tell your neighbor. Correct answer is A. All right, here's the path of no refraction. B, there's no bending. As you go from air to water, it's going to bend. Okay, here's our normal line. It's going to bend towards it. This is away from the normal line. Towards it. Okay. Here, all right, so when I was in your shoes, I was like, yeah, okay, I'm good with the fact that it like slows down, speeds up when it changes medium. That doesn't. But why does it have to change direction? I mean, when I'm in a car and I hit the brakes, it's not like I'm like oh, I hate that. And hit the gas like why does changing speed mean changing direction? Good question. The answer is light is a wave. This is a refraction is a consequence of a wave changing mediums. Here's an analogy. Okay, you're in a wheelchair. Okay, air is sidewalk, water is grass. wheelchair can travel faster on a sidewalk than it can in grass. You right with that? Okay. I'm rolling. These are my two wheels. Okay, we're looking down from above. As this wheel goes off of the sidewalk into the grass first, what happens to its speed? Slows down. And the consequence to that, slowing this one wheel slowing down first, means it's going to do what? Pivot until both wheels are now in the grass, and now we're going together. Okay? The reality is there's a wave front, and this part hits transitions first. Okay? Good with that? Tell your neighbor. Correct answer is come on, kids. This is just factoids. Always, always, always in light, we measure the angle from the normal line. Okay. Remember, angle of like law of reflection, angle of in equals angle out. We measure those from the normal line. Always from the normal line. That's our angle of refraction. Okay. Tell your neighbor. Correct answer is? Correct answer is C. Here's our weight. We're going from a high index of refraction to a low index of refraction. We're going from slow to fast. It's going to bend away from the normal line. Here's our wheelchair analogy. We're going through the grass. This gets on the sidewalk first. Speeds up. Now we're both on the sidewalk. Okay? Good? All right. Again, I'll do it for this half first, and then that half over there. Okay, going from air to water, bending the normal line is perpendicular to the surface, bending towards the normal line. Okay with that? Everybody got it good. Okay. Hopefully I don't zap you guys. Going from water into air is going to bend away from the normal line. See that? Away from the normal line. Good? Okay. Y'all. Going from air into water. Bends to the normal line is perpendicular to the surface. Bends towards the normal line. As we go from water into air, it bends all right, video people, just trust me, it goes away from the normal line. Okay, good with that? Okay, now, just throwing this out here. Not a big fan of memorization, but something, I mean, you could reconstruct it. It's just a lot of reconstruction to do from the math. I would highly recommend memorizing something. There needs to be a first foundational step. For me, it's this demonstration. I'm very visual. I know I have a snapshot in my brain what light does when it goes from air into water, bends towards the normal line. That's my starting point. And I build everything from there. Okay. You could memorize, hey, when it goes from fast to slow, it bends towards the normal line. You could memorize, hey, when it goes from a low index of refraction to a high index of refraction, bends towards the normal line. Some factoid would be helpful to have in your brain as a starting point. That makes sense? And like from there, you can build on from that. Okay? I don't care what it is, but something needs to be. Okay? If not, you can math it. But that's going to take you a while. But, you know, if you're desperate on a test, probably not a bad approach. Okay? So, a ray of light goes through water and then enters glass at an angle of 28 degrees. What is the angle of refraction? So before we do the math, what are we going to predict? Is it going to bend away or towards the normal line? Just think. Thumbs up when you got something. Is it going to bend away or towards the normal line? And so is your angle of refraction going to be bigger or smaller than 28 degrees? Tell your neighbor what your hypothesis is. Okay, this is what the question that I'm asking is a great test question. Okay, if you get stuck, you can make up some numbers and math it. Like I'm just going to do, like I'm giving you numbers. The math is not difficult. Okay, so I'm using Snell's law. Okay, whatever I start in is 1, whatever I end up in is 2. Pretty straightforward. All right, the index of refraction on a start in is water, so I have 1.33 sine index incident angle is 28 degrees. That's theta 1. I end up in end up in glass, and I'm looking for the angle of refraction. Make sure your calculator is in degree mode. I'm just going to math this out on the calculator. 1.33 sine 28 divided by 1.52, you get 0.41. Sine 32. Inverse sine it. And I find that to be 24 degrees. How did that match your hypothesis? It bent away or towards the normal line? Towards the normal line. So we always reference the angle from the normal line, so that angle is going to get smaller. Good? We've seen how the math and the theory correlate. We always measure from the normal line. Okay? Yes, how we doing? Give me a confidence rating. 5, rocking it out. 0, like.
Bigger end.
Okay? Tell your neighbor. Have a conversation about physics, this physics question in particular.
I've been having 3 years in a row. Geometry 1 CS.
Correct answer. What do you say? Correct answer is A. No refraction. Here's why. When you go straight on from the sidewalk into grass, both wheels are hitting the grass at the same time, both slowing down. It does slow down, it just doesn't change direction. Okay? So when you hit perpendicular to the surface, no refraction. Okay?
So we're saying it's start. And it goes.
It starts in
Tell your neighbor. I have one pass.
Oh, wait, what am I doing?
And just water. Correct answer is Correct answer is C. The greater. Here we go. Bring it in. Give you toys. I know it's tough. As you go from if it goes from a greater contrast of index of refraction, the greater the change in speed, the greater the bending. Okay? This is in the wheelchair analogy, this is the sidewalk, this would be grass, this would be mud, this would be sand. You ever tried to ride your bike in sand? Does not go well. Okay? Alright, so just gave you a cup. You're going to buddy up with somebody. Hold on before you start picking people. There's a black dot, or there's a dot in each of these cups. What you're going to do, one person is going to fill their cup up with water from the sink. Make sure you don't turn on full blast. It'll knock your cup out of your hand. Fill it up. While one person's filling it up, the other person is taking their cup, placing it on a table, lab table, something, the dot away from you, far side of the cup, and then back up until that dot disappears below the rim of the cup, and just stay there and watch. The other person's filled their cup up with water, pours their water into the other person's cup. It does not have to be slow, but don't go so fast that it knocks the cup over. Okay? Once you've observed, trade rolls. Okay? Go. So you want the black dot, you want the dot to disappear. So you want it to go away.
Probably easier to
Okay, there's the black dot. Black dot disappears. Pour in the water. You can see the dot. Okay, flip rolls if you haven't. All right, once both have done that, take that, put that upside down on the back table, dump the water out, do the same. Go back here on the back table.
I don't think I was willing to say that. All right, so
initially, light is coming off of the dot in all directions. All right with that? It is not the source of light, it is just a reflecting light off. Okay? That ray of light that would have gotten to your eye is blocked by the edge of the cup. So you can't see the dot anymore. But then we pour water in, and all of a sudden, it's like, oh, I can see it. Why? Because so your eye is not the emitter of light. Your eye is the catcher of light. You are not like laser beam eyes, okay? Light is going into your eyes. So, light is going from water into air. What is it going to do? Bend away or towards the normal line?
Away.
It's going to bend away from the normal line. So I'm going to look at this guy. Our normal line is here. Yes? It bends away from the normal line into your eye. And you can see it. But you think you see it, not where it is. We don't assume light bends. We don't look at something like, oh, I see it over there, so that means it's over there. That's stupid. It's like it is where we see it. And so we think we see light going in a straight line path. This is the apparent depth. We think we see it there. You all right with that? Shallower than it is. Okay? So we assume light doesn't bend. And it goes in straight path. Okay? So that's the apparent depth. On the homework, I'm going to ask you to calculate the apparent depth. Okay? This is a little bit of an involved problem. It requires a lot of steps, but no one step is crazy. Okay? The first step would be to look at the angle of incidence compared to the angle of refraction, doing Snell's law. Okay with that? Then, so the actual depth would be this depth here with this triangle from the original ray. Okay with that? Theta 1 being part of that triangle. Here's the actual depth. Your apparent depth is this. That's your apparent depth. That makes sense? And we're going to use this triangle to figure that out. Using some trig, theta 2 and this angle are congruent. Because this one we're going straight on through. Link triangles. Good? Yeah. So you're looking for that. Okay. You guys ever read The Hatchet?
Elementary school.
Best middle school read. Okay. So here's where the fish actually is. Where does the fish appear to be? There we go with that. Okay. So if the fish appears to be here, where should you aim?
Below.
You should aim where the fish actually is, which is below. Good at that? No one ever asks, what does the fish see? I mean, what's the fish's point? Now have a conversation with other people around you.
Like those What?
See, I think it's A, but like, I don't think it's
Because the heights received.
now it's the
Hey, Parker, you might like it. I don't think it's. I don't know that
Correct answer is, what do we say? Go. So, the fish's eye is the receiver, the catcher. Okay. Light's coming from the guy into the fish's eye. So it's going from air to water. What is it going to do? Bend away towards the normal line? Going to bend towards the normal line into the fish's eye. So the fish sees things in a straight line path. Fish thinks it sees A.
How joining is how joining is
It is above, yes?
No.
Okay. All right, so some examples. Frosty mug root beer. So good on a hot July day. It looks like it is brimming full with root beer. But if you've ever thought like the glass is super thick, you're only getting that much root beer, even though it looks like you're getting that much root beer. Oh, got had. Okay, because the light is refracting, and it looks like it goes from edge to edge. This is how you get wavy lines in a pool due to refraction. And here, we're obviously not decapitating people or animals. All right? If you look, you can't see it from this photograph, but you can see it from this one. The edge of the pool, we're not making the photograph straight on. It's at an angle to the pool. So obviously the guy's body is literally here, actually here. Light is coming from water into air, bending away from the normal line. And we think we see the person's body there. Look at that. Yeah. And then you can have some fun with cups today. The water. See what happens. Yep. Your homework is another pre-quiz. There's a worksheet. So the pre-quiz is due tomorrow. The pre-quiz, sorry. I say that right. Pre-quiz is due tomorrow. Worksheet is due Thursday. It's a bigger worksheet. Worth twice as many points, kind of like a review worksheet. There's 10 problems. You know how to do the first side. Okay?
Yeah, I did see
That'll be
that.
due on Thursday. Yep.